Welcome everyone. We are interested in drawing the Lewis dot structure of NO3 minus ion, which is known as nitrate ion. Now in order to draw the structure, we need to find out the valence electrons of the different atoms present in this molecule, which are nitrogen and oxygen. So the electronic configuration of nitrogen is 1s2, 2s2, 2p3. I've drawn the orbital diagrams for 2s and 2p because we are concerned with the valence subshells and valence shells as well as valence electrons. Now in 2s subshell you've got 2 electrons because it is written 2s2, and in 2p3 you've got 3 electrons, 1 2 3. So its valence shell is the second shell having valence electrons 2 plus 3, which is 5 valence electrons, 5 VE, 5 valence electrons. Okay, so also you've got 3 unpaired electrons in 2p subshell, which means that nitrogen can basically make only 3 single covalent bonds, and the fourth bond which nitrogen makes is a coordinate bond. How? Because see, you've got 3 unpaired electrons which means 3 single bonds. Now the fourth bond can be a covalent bond due to the 2s2, means that you have got paired electrons, and that lone pair, that these 2 electrons is a lone pair and can be donated to a electron deficient atom, electron deficient species. Now talking about oxygen, its electronic configuration is 1s2, 2s2, 2p4. I've written the orbital diagrams 2s and 2p. 2s is having 2 electrons whereas 2p is having 4 electrons. Its valence shell is the second shell having valence electrons 2 plus 4, 1 2 3 4 5 6 valence electrons, and you've got 2 unpaired electrons, which means it will make 2 single bonds. Right, now talking about O minus, if this would have been the case, O minus, then its electronic configuration would be 1s2, 2s2, 2p5, because negative charge means you have gained an extra electron, and its orbital diagram would be 2 electrons in 2s subshell whereas 5 electrons in 2p, and now the number of unpaired electrons is just a single unpaired electron, and which means that O minus will make a single bond, but it's the number of valence electrons are 2 plus 5, which is 7 valence electrons. Now remember this. Now let's proceed to the structural part. So you've got nitrogen as your central atom having 5 valence electrons, 1 2 3 4 5, right, and you've got 3 oxygens, and one of them is having a negative charge, which means this oxygen O minus will make a single bond with nitrogen, whereas these 2 oxygen atoms will make 2 bonds with nitrogen. So you've got oxygen on top of this, on top of nitrogen, having 6 valence electrons, and as I said that oxygen has 2 unpaired electrons, which means it will make 2 bonds. And O minus, let's draw the O minus. O minus has 7 valence electrons and it had just a single unpaired electron, which means it will make just a single bond with nitrogen, 1 2 3 4 5 6 7. So it has 7 valence electrons, whereas now you've got your third oxygen, which is a normal one, having 6 valence electrons. Now let's proceed to draw the bonds. O minus will make a single bond. This oxygen will also make a single bond. So this electron is represented by this electron. These 2 electrons are this one and this one. So it has been filled. See, if you donate these electrons, this electron is for O minus, you got it here, and these 2 electrons are from this oxygen and you got it here. So your electronic configuration is now stable, but you got the third oxygen also. So I said that nitrogen can make the fourth bond as a coordinate bond. So nitrogen will simply donate this lone pair to oxygen, and these 2 electrons will be accounted for both nitrogen and oxygen. So nitrogen, after donating its lone pair, will gain a negative charge, whereas oxygen will gain a positive charge. Now one might say that the structure is having 2 negative charges and 1 positive charge, whereas in this case we have written NO3 minus. So see, this negative charge and this positive charge are cancelling each other, and we have got just a single negative charge as our spare, which is why we have got just a single negative charge written here, NO3 minus, because these two charges are going to cancel each other. So let's count the number of electrons after bond formation. For O minus, 1 2 3 4 5 6 7 8. For this oxygen, 1 2 3 4 5 6 7 8. These two have completed their octets. Talking about this oxygen, 1 2 3 4 5 6, and for the coordinate bond also has 2 electrons, so 1 2 3 4 5 6 7 8. Okay, so this oxygen has also completed its octet. Talking about nitrogen, 1 2 3 4 5 6 and 7 and 8. So this nitrogen has also completed its octet, and this structure is now a stable one, where every atom has gained stability by completing its octet, or by gaining or by achieving stable electronic configuration, or you can say they all are having now 8 electrons in their valence shell. So this was the structure of nitrate ion. Thank you for watching, and I'll see you guys in the next video.